we can do so. Yes,
And
it's 1 minute after 3. Yes.
Yeah, and I'm recording the seminar just to inform you all about that.
Okay, great. Thank you, Eric. So, hello, everyone. My name is Jana Zillmann. I am Research Director at CICERO, the Center for International Climate Research. And I'm happy to welcome you to today's webinar, which is a joint webinar between the CICERO Climate Risk activities and the Knowledge Action Network on Emergent Risk and Extreme Events. And there we have the working group, Modeling and Insurance, that is chaired by Alessio Puglio from the University of Bern and myself. And within this working group, we host regular webinars every month about, and you can find more information about the webinars on the RiskCon website, the past ones and the coming ones. And these webinars are all recorded. So today I'm very pleased to have Professor Juergen Scheffran with us. He is professor at the University of Hamburg, professor of geography, and he is chair of the research group on climate change and security at the Center for Earth System Research and Sustainability and the Excellence Cluster on climate change and society. And he has originally been trained in physics, but he, throughout his career, worked in diverse interdisciplinary research groups on the topics of climate, complexity, and conflict studies at the University of Marburg, Darmstadt, Paris, and Illinois in the US, and also at the Potsdam Institute for Climate Impact Research, PIC. So I'm very pleased to have you with us today, Juergen, and we usually have a 30-minute time slot reserved for the presentation that will be then followed by a discussion. And I invite the audience to either put comments in the chat already during the presentation, if there are comments, or after the presentation, or if you want to speak up, just put an exclamation mark in the chat, or just speak out, and then we can hear your question.
Jana, if they press click the reaction, they can raise hand.
Yeah, there is also the raise hand. Yes, yeah. Even easier. I'm still in IPCC modus. We obviously need to put the exclamation mark. No, but yes, if you have this reaction button, use it and raise your hand, or whatever option there is to signal if you want to ask a question after the presentation. So I don't want to waste any more time and give the word to Juergen to start your presentation. So.
Thank you, Jana, Eric, and Alessio for organizing this meeting, and welcome everybody here to my presentation. As Jana mentioned, I have a background in physics, and I'm now in geography and had also some time working with political science and social sciences. So this may be something that could be combined with this topic, tipping points, cascading risk and conflict in hotspots of climate society interaction. And I'm trying to bring these different things somehow together. First of all, I want to start with the question how human societies respond to climate change. And it can be two different ways of responding. One is the conflictive pathway here marked in red with security risks, instabilities, and migration and conflict. But it could be also a cooperative response. The green pathway with risk avoidance, adaptation, stabilization, and conflict resolution and cooperation. And which pathway is taken is basically determined by human action. Well, this shows the overall complex relationship between the different systems we are talking about here, both in the natural sciences and the social sciences. On the left-hand side, you see the climate system with its key variables like temperature, precipitation, extreme weather events, and other variables. Then you see natural resources like water, land, ecosystems, and biodiversity, which are interacting with the climate system. On the right-hand side, you see human security dimensions, which are important for human beings, like the different resources needed by humans, including energy and food and water, but also health and income and livelihood. And finally, humans are forming a society which has a certain stability or instability, and these are the key events that are driving this dynamics in society, like political events or migration. And in our context, very relevant is violence, conflict, but also cooperation at institutions. And these are interacting through various linkages, like stress factors, impact factors, and risk, and the responses and the interactions between humans and their society. In the middle part, you see various variables like vulnerability and sensitivity factors, conflict sensitivity in particular, and also the possibility to control this relationship with adaptation strategies, resilience, and other concepts. So now, when you look at the question whether climate change leads to conflict and how conflict affects climate change or climate adaptation, there have been now a number of studies, and we took part in this systematic reviews some time ago, partly published in Science and other journals, looking at the previous studies that were trying to find and look at this climate conflict relationship. But actually most of the empirical studies at that point in 2012 found actually a link between climate and conflict, but only 16 found a significant link, 6 found no link, and 5 an ambiguous link of the 27 empirical studies. And the relationship is still contested, and there have been many other reviews after that study now, more than 20 or 30 systematic review studies. So the long-term historical studies find a strong coincidence quite often, in particular in the Little Ice Age times. The results are more contested for recent periods, and local violence has been seen as more likely than interstate wars, it's the so-called climate wars. We don't know what the future will bring, but we can say that the climate conflict is aggravated by various variables, in particular high population growth or low level of development and low economic growth, also medium levels of democracy, ethnic diversity, political instability, and previous violence in the vicinity of the conflict. The situation regarding data has substantially improved since then over the last decade in terms of georeference data and advanced statistical models trying to understand this the relationship between climate and conflict variables. And the conflict risk can be moderated, for instance, by adaptive capacity, human development, and by cooperation. So cooperation can be also a possible response, even though the data is less advanced in terms of the link between climate and cooperation. But the research is also taking on this issue now in recent publications. The key issue, I think, in recent years has been looking at the conflict pathways, in particular climate hotspots. And this is also a topic of this presentation, including water, food, weather extremes, migration as possible conflict linkages, but also the role of climate policies, which can help to reduce the conflict, like mitigation, adaptation, or geoengineering, but also can in some cases increase conflict, because each of these policies has some conflict potential in itself. Now, one of the most recent publications has been extensive review and expert assessment that was published in Nature in 2019 by a group of experts that was trying to analyze this relationship based on the previous literature, in particular to understand this relationship between conflict risk and climate risk, which can be mutually enforcing, but in some sense could also be moderated by the role of government and their policies and governance mechanisms, and by the role of groups in the society that take certain adaptation strategies. According to this evaluation, in the past, the most influential conflict factors have been low socioeconomic development, low state capability, intergroup inequality, then also economic shocks, political shocks, population pressure, natural resource dependency. And you see only at the very end, according to this expert assessment, climate variability has been a major relevant conflict factor in the past, but it's also identified that climate change is the most uncertain of all the conflict factors in the past. And this may change in the future, because when we talk about the evaluation of the probability of substantial increase in conflict risk, you see that for the past, according to the different experts, the average was about 5%. With a 2-degree scenario in the future, this might increase to 13%, and with a 4-degree scenario, this may increase to 26% on average, with a wide range of different opinions of the experts. So in the future, climate change may have, according to this evaluation, a continuously increasing impact on conflict. Now, the main question is, where does this conflict occur, and what are the locally specific conditions in these different regional hotspots? This map was also drawn 10 years ago, published then, and looking at the various areas that are sensitive to climate change and security implications. These are the areas which you know, like the Sahel zone, the Mediterranean area, sensitive to water and food problems, but also migration. And Southern Asia, where we have flood and storm events, and as well as in Eastern Asia. These are also areas affected by migration patterns. Then you see Central America, South America, also part of the Pacific region, where migration patterns can combine with storm events, flood events, as well as sea level change. And the Arctic region is seen also as very sensitive region. But now in the research group, Climate Change and Security, we had done a lot of regional case studies in all these areas, more or less. Mostly you see in Northern Africa and the Mediterranean, as well as in South and East Asia. And increasingly also, we are looking at Latin American cases. I can only give examples here. And one of the most well-studied regions in terms of climate security risk is Kenya and Uganda. And it has been a top-down approach, looking with GIS-based maps on different factors that determine conflict risk, like the exposure to environmental change in this area, in particular temperature and precipitation change. Then the blue color indicates vulnerability factors, in particular in economic and social factors like poverty, income, and so on. And brownish yellow part includes conflict risk based on previous data. And then the fourth map is the combination of these factors: exposure, vulnerability, conflict risk, leading to a combined risk indicator, where you see the aggregation of different factors in these two countries, and where the most sensitive regions to conflict risk are. You see Uganda as well as Northwest Kenya, but also around the capital in Kenya. And the dots indicate the location of the real conflicts in a decade. So this is more the top-down approach. In addition to that, you can have field research. You go to these countries and talk with people there. What are the reason for conflictive or cooperative relationships? And this is when you go there, you see that there are water problems, there are food issues, and there are also conflictive issues like the oil discovery in Northwest Kenya. as well as the wind park on the Lake Turkana, which could be a useful development project, but could also enhance the conflict in this region. And when we did this study a couple of years ago and published this to see also what is the role of the energy projects on the conflict situation in this region around the Lake Turkana, you see that oil and wind, when you compare them in the table, that the oil conflict has a medium to high conflict intensity, the lower is for wind. But the key drivers are the community expectations for additional welfare and income from these development projects. And the conflict object is often the employment of people and the competition among the different groups for employment. And the protest forms are often roadblocks against the projects, as well as lawsuits. And here you see the complex relationship between the different actors in this region for the demand for oil and the demand for renewable energy, global drivers, local drivers, interacting with each other. And you see the different actors here. The national government, for instance, has an impact on both conflict on wind and oil. And there's often a conflict between some of the groups like the Pokot community and the Samburu community in competition for the employment and job for which they have high expectations. And many of these interactions are positive in the sense of cooperative relationships, but there could be also conflictive relationships, in particular between the Pokot and the Samburu community, driven by these new development projects, together with the existing problems of climate and conflict in this region. Now, conflict is not the only possible response in Kenya, and there was another case study by a PhD student in southern Kenya to understand the role of actors and social networks that are evolving in governing the natural resources and how the different actors work together in these networks. And there have been networks identified in the agricultural sector in green here, in the wildlife and tourism sector, in the water sector in blue, in the community management in orange, and how they are all connected and interacting with each other and help to reduce conflict. Actually, this is a less conflictive region than Northwest Kenya, partly because of these stabilizing social networks in this region, which indicate the self-interest of the different group in avoiding conflict. Now I try to move on. There was a comparative assessment for the linkage between climate and violence in two countries, Kenya and Sudan. It was published a couple of years ago to understand the complex relationship. And the role of climate change is a risk multiplier that interacts with human insecurity and instability, and the compounding risk that can evolve because of the double vulnerability to violence and to environmental hazards. And this is often the case that these two risk factors are mutually enhancing each other. There is a call for agent-based approaches to understand the interplay between the capabilities and the motivations for violence and for conflict and cooperation in these regional hotspots where there is an erosion of social order, state failure, and violent conflict. And what you often observe is this so-called spiral of violence. As you see here, there are various factors that lead to, from political secession effects, the insecurity of people and the arming of some factions which are fighting each other in a violent way. And there are violence multipliers such as socio-economic marginalization. The oil revenues add to this, the refugee movements, division between farmers and herders, climate change and resource scarcity also seen as violence multipliers. But it's also possible to prevent violence by good governance, by human development, by climate adaptation, resource sharing, and flexible boundaries and peace agreements. And there's a competition between these two factors, whether the spiral of violence is increasing or decreasing. And here you see the complexity of these interactions, which you also studied for another regional case for the Jordan River region, which has been long a very conflictive region. And in a so-called biotip project, we looked at this region and had some meetings with local stakeholders, Palestinians, Israelis, and Jordanians, trying to understand the social and natural tipping elements in this conflict situation. And it was published in 2019. So we were looking at in a kind of co-design of these different actors to understand the key elements of the tipping points, local and regional differences in rangeland degradation and the transboundary cooperation, which is also evolving, which in the sense of peace building could reduce the conflict between the stakeholders, and the sustainable management of natural resources, even in highly contentious conflict areas. And one of these graphs created in this assessment of stakeholders in their meetings was to understand what they think are the most important factors in determining the tipping elements, like water quantity, the rangeland relevance, and the transboundary role of that, and key species, agriculture, afforestation. You see the relevance is declining. Marine coral is not so relevant, obviously, for this region. And important species in arid land, and it's again increasing in the relevance according to stakeholder perspectives as factors affecting tipping elements. So this is a ranking exercise. Now, moving on with the understanding of social networks, as you see, was a very important factor in trying to stabilize, but in a sense could also be a conflict factor, the social network, depending on the interactions between the key actors. There was an analysis based on the destabilizing events that happened after the economic crisis in 2008 and the cascading events and the domino effects that occurred after 2008, as well as the Arab Spring in 2011, which led to a fall of several governments. And in the same year, there was also the Fukushima reactor disaster, which had also leading to some tipping elements and cascading crisis. So this paper by Yasmin Kominek and myself was looking at the role of agency in helping actors to learn from constructive behavior of others and follow them and induce collective transitions, which was obviously happening in the Arabic Spring situation. The social learning is a very important factor here in determining the role of networks in collective tipping, and the role of contagious events, where the spreading of certain ideas or protest movements across the whole region, starting in Tunisia, then all of North Africa, and the chain reaction and reached also even Syria, the Middle Eastern countries, and triggering conflict in these areas. We also identified the importance of complexity science and understanding the thresholds for complex adaptive systems, such as self-organization and micro-macro transitions. And both of these factors were discussed then for the Arabic Spring situation, the collective group behavior there, the crowding behavior in this swarming in this area, and the Fukushima explosion in 2011, which was a local event, was triggering global action chains, reaching even Germany and inducing energy transition in Germany. So you see local and global effects can be closely connected with each other. Okay, in this complex world, as you see, is tried to symbolize here in this graph. On the outside, you see certain critical events, different risks, which can be compounded to connecting factors in the middle. And the events outside are, for instance, the economic and financial crisis and the hotspots of insecurity, political destabilization, refugees, and violent conflict, and the instabilities in the climate system and the food, energy, water nexus. The connecting factors are in the middle, which are kind of the multiplying, connecting all these different events with each other. I put first globalization, which is maybe as relevant as climate change, maybe even more relevant than climate change, resource flows, diseases and infections, media and social networks, transportation and communication, and all the markets and the supply chains, connecting all these areas. So if there's a problem somewhere, it leads to a problem elsewhere. And that was clearly an issue in the Arab Spring as well as in the Fukushima disaster, but in many other events that occurred after 2008, I would say, and 11 and 2015, and all the chain of events that occurred. Okay, so this initial graph I showed you, this choice between the conflictive pathway in red and the solution and cooperative pathway in green, leading towards resilience, sustainability, and cooperation, is not a one-time choice. It's a sequence of events. You can call it a cascade of tipping points, of cascading transitions. And it's well possible that for some time you move on the conflict pathway down, but that makes it, of course, more difficult to move upward towards the cooperative pathway, but it's not excluded. You can still, even if you in a conflictive situation, try to find solutions and move up to the solution pathway. That's well possible. And that gives some opportunity and hope for change, even in bad situations that we had in recent years. Now, what is the role of agents in this regard? You see an example for two-agent interaction under conditions of climate change as well as social and political change. The blue actor and the red actor, and both have resources. In the middle is basically the ability to act. And this ability can be used for creating wealth, and it can be used for creating violent force. It can be used for conflict and cooperation, again, simplifying this. And yeah, if both sides switch to the wealth creation, the cooperation, this can trigger a cycle of cooperation, but it can be in the other direction, lead to a cycle of violence and conflict if both switch to the violent force instead of the cooperation. And both cycles of cooperation and violence can be quite stable for some time. It's very difficult to make that switch, but it's not excluded. Okay, now I'm moving from this more qualitative description and towards the attempt to model this relationship, which is based on my work in physics, complexity science. And I've been trying to develop a model, for instance, of the Darfur conflict in Sudan, and that was taken up by Science and a special issue on complex systems and networks as an example. And they made the suggestion that physics can help in understanding some of these social interactions. And I come back to my initial graph now in the model framework. We have climate with variables and interaction between them. We have natural resources and the interactions between them, like biomass, land, food, water, fish. We have variables in the human security framework, like the capabilities of humans to act and the values they follow and the actions they take. And each of these agents can then interact with other agents and to form social interactions. And particularly, I'm interested in the relationship between conflictive interactions, cooperative interactions, as well as the role of migration in this regard. And yeah, of course, the key questions in our context is when is there a tipping in qualitative change, or when certain cascades occur? How can sustainability, viability help to stabilize this relationship? And what happens in the middle when you talk about the compounding effects of all of these boxes with each other, because they are not disconnected. Now, this goes back a little to my physics background. That was 40 years ago. In my diploma thesis, I studied the relationship between complexity and stability. And I think there's still a relevant question whether the increasingly complex world leads to more instability or less instability. And this is still a contested issue. You find in our articles arguing in favor or against. Still, since the 1970s has been discussed for the ecosystems, but it's also important, of course, for human environment interaction, what the role of complexity is in this. And generally, in my thesis, I came to a conclusion that systems disappear which are too little adaptive to environmental change. and that the stable systems remain. So these are the ones that in the end remain, but there is always a transition in change. And this would suggest that in evolutionary process, there's an increase in complexity and stability in the world, despite temporary instability. And the complex systems can be measured with different types of indicators, many complex indicators like entropy, connectivity, hierarchy, computation effort, and cascade complexity, as well as different stability indicators like Lyapunov stability, eigenvalues, exponent, and attractors. And the chaos theory in the 1980s was very prominent. After I published this, the Santa Fe Institute and others had strong interest and raised a lot of interest also in the public on this subject. Now the question of instability is usually in systems you have a stable area where the system can digest some disturbance within this limit. But if the same disturbance is on the edge towards instability, the same disturbance can have a large effect, particularly when you have a change of the eigenvalues of the system. And it's also in a, say, two-dimensional framework, two instability indicators. The combination of disturbances can also lead out of the range. So two factors can combine to instability. That's a possibility. What's also relevant, I found in this thesis, was the role of cascading complexity. And this can go back to semigroup theory and transition research and system science, where the combination of hierarchical analysis can be used to understand the complexity of transitions. Sorry for the bad graph, that was before the PC was invented. Now, coming back to my graph, I first want to take a system perspective. We have, again, these four boxes, and these four boxes are connected with each other in positive and negative ways. You have positive linkages, negative linkages, and these can combine to instability, but could also have a stabilizing effect, depending on the pluses and minuses when you look at that relationship. And I want to just give an example how the amount of change and the slope of the sensitivities between the different variables is a key issue. Here we have the four variables in these boxes: temperature, natural resources, human security, and societal stability in an idealized framework. And you see the linkages, the slopes are the sensitivities between two variables, like between temperature change and natural resource change, or between natural resource change and human security change, and so on. And you see if the slope is low, then the initial impact of temperature change disappears when it reaches societal instability. So it has a minor effect on societal instability or stability. But when the slope of the curve increases beyond a tipping point, you see the slope suddenly increases, then the temperature change has a much larger effect, particularly when you have tipping points between temperature and natural resources, or between resources and human security, or between human security and society. Then suddenly you have a very large effect, simply because you move above a certain tipping point, when the combined effect then has a large effect on society, and in particular conflict. Now, I've been trying to model these relationships for quite some time, since my PhD thesis, to develop an agent-based model to understand the role of humans and their interaction with systems. And again, I have here the capabilities of humans, which they can invest in certain actions to change systems, like the climate system, which then has an effect on human values. And you have a cycle of interaction from one time step to the next. The humans can try to improve. In particular, when you have multiple humans and multiple action pathways, which can interact in very complex pathways. And the key variable here is the priority of humans for certain actions, which can change. An example is here only here some of the equations of the model, like the relationship between value change of one actor and the combined effect of the capabilities of all other actors, and a change in the priority, delta P, as a function of the marginal value of the outcome. Now, we have a complex interaction between n players, you have n times n interactions, and the F's are the coupling terms in this interaction. And the question is this interaction matrix between n players or n agents stable or not? And that depends on the eigenvalues of this interaction matrix in particular. And for a two-agent interaction, you have the rather simple case where you just have the determinant here, which is F11, F22 minus F12, F21 is the self-effects are larger than the external effects from other agents. If this is larger than 0, then you have a stable interaction between two players or cooperative relationship. If it's getting negative, then you have a destabilizing relationship. Okay, this instability can be seen as an indicator for the tipping. Now, did I apply it in my PhD thesis? It was published in 1989, and the model was published the first time. And I applied it to the East-West conflict, which the principle was rather simple. It was only two major powers, but it can lead to complex interactions. I just had different arms races simulated here. You see 10 different arms races, depending on a worst case parameter, the worst case perceptions by the USA, United States, and the Soviet Union at that time. And for worst case, W equal -1, you have an arms race, okay? The nuclear weapons are increasing. And when it switches to positive or worst case, so best case assumptions, then the arms race breaks down with a chaotic transition in between, and it leads to a disarmament race. I did the simulations in June 1989 and published it in October 89 and defended it in December 1989. You know what happened in between? In October, between October and December, all the East German governments broke down, including the East German government, in some call it a chaotic transition with the fall of the Berlin Wall. Okay, in a sense, it was started with a communication between Reagan and Gorbachev, the leaders of the two superpowers, which switched from worst case to best case, in a sense. They became friends, at least temporarily, and the Berlin Wall was falling, and the nuclear weapons was increasing, as you see, till the mid-1980s, and then was declining. It was a tipping point in the nuclear arms race. The model was then applied to a situation in the post-Cold War world, and you see a cascade of bifurcation points in response to the strength of the response of the different agents, leading from stable equilibrium points to more and more chaotic situation. And when you see the situation after 1990, initially it was stable, but it was getting increasingly unstable, and we experienced a cascade of destabilizing events, which are published in some publications here, including the book A World at the Edge of Chaos by Kowalski. Now, coming to the end, we are not talking only about conflict, but also cooperation, which is also having a transition, a multi-level transition, from the global level to the citizen level and the nations and municipalities in between. And this is part of the complexity, this interaction between these different agents and the transition between the bottom-up and top-down approaches, which was published in this handbook on sustainability transition and sustainable peace. Now, I would end with a question is, under which conditions do agents form larger coalitions by cooperating with each other? And I use the example here of the relationship between energy providers and customers. The customers invest into energy companies so they can fund in their energy pathways, high and low carbon energy pathways, to achieve value for the providers as well as for the customers. And under certain conditions, you see a switch between the different coalitions, between high carbon and low carbon coalitions, depending on how the agents behave, or the individual customers invest into these two different pathways. And in this simulation that both the customers as well as the providers are benefiting from this coalition formation process, but there is a clear switch. Some of the customers switched to the new pathway, and some customers stay on the old pathway. And there's a kind of differentiation between these two. So we can discuss under which conditions basically everybody would switch to low carbon. That would be an interesting question to discuss. Okay, this is my last slide. See again the complexity of the interaction here of the different variables that was published in the book by Jana Zillmann to understand the relationship between climate extremes and conflict dynamics. Again, we have the four boxes. We have climate change and we have conflict. We have the role of human actors, and we have the physical environmental conditions which connect with each other in a certain way, that under some conditions it becomes overcritical in the middle. You see that switching between two different states, tipping points, depending on certain mechanisms and pathways, and how all the factors influence that. And that's my task and challenge for the future, trying to model this, to get a better understanding. Okay, with this, I think I want to finish and conclude, and I'm looking forward to your questions.
Yes, thank you very much, Juergen. I'm welcoming everyone to ask questions now. I don't see anything in the chat so far. Now I have a question in the chat from Dimitri. Thank you for a very interesting presentation. From your experience of modeling socio-natural systems, is a more complex and detailed model always better than a simpler one? Or is there the optimal level of model complexity for any particular research problem?
Yeah, every model needs to be adapted to the problem. If it's a simple problem, you would use a simple model. If it's a complex problem, more complex model. So I would call it adaptive complexity of the model. It really depends which problem you are trying to analyze. And just to mention, some models are reducing the complexity by adaptive processes, eliminating some key variables which are not necessary.
I hope that answers your question, Dimitri. Otherwise, speak up if you want to follow up. There's a question in the chat if this talk has been recorded. Yes, it has been recorded. I saw people were joining basically 10 minutes ago. So yes, you can listen to the presentation. There, I have a question from Carsten Haustein. Please speak up.
Hello, everyone. Yeah, giving it a try. I mean, that topic is just too much. And these slides didn't make it easier, because that must have been the presentation with the most complex slides I've seen in a while, which ironically is something I'm sort of familiar with. One of former colleague, she used to work on that very subject, Lisa Thalheimer. I'm not sure you heard her name. She's wrapping up her thesis. And ever since she has been working on that, I was wondering, how do you even tackle that? And like this presentation again gave some interesting insights. But I guess my question is, do you sense, because I absolutely don't, do you sense that there has been made some progress on like our understanding of this conflict climate change conundrum or nexus?
Yes, I would say so, because the division in the community has been much larger 10 years ago. And the division was largely those who see climate as a dominant factor and others see social science factors being dominant in conflict. There has been some approaching of these communities, and there have been in some collaborative work like this Nature article, which included some of the scientists with the controversial positions on this, at least an attempt to bring them together. And so I think there's an approach between them, and the point is that it's a combination of factors often. It's a single climate change often as a sole single factor rarely leads to violent conflict. Okay, but together with other factors, in particular, there's the fragility of certain regions. If a region is already fragile for various reasons, it's much more sensitive to climate change. And we have seen the increase of fragility in some parts of the world now, partly because of globalization and other factors. And for that reason, it's hard to say, is it more globalization or is it more climate change? But in the end, it's the combination of these two.
Yeah, thank you.
Very quick follow-up, if I may. And I know there have been other people asking questions now. Is it okay if I say, because this is what I tend to do, to make people realize that climate change isn't just about extremes or heat waves or changes in weather and climate, it's about increasing risks for conflict. Is it fair? So from what I gather in your slides, that's definitely something that can be backed up with evidence. But is it fair to say that one of the main problems with climate change is risk for increased conflict or increased risk for conflict?
Climate change makes life more difficult. It's undermining human livelihood, and it's challenging people. And the challenge is a driver for action. And the driver for action can lead to conflict in the sense that you try to have your own benefit at the cost of others, but it can be also a driver of taking action in collaboration with others, because both are better together. So it's a driver of human evolution, if you wish. It accelerates human evolution. It forces societies and people to adapt and adjust and find ways out of this mess.
Thanks.
Very well said. Thank you, Juergen. We have lots of questions now. One question is about if you could elaborate a little bit more on what you mean by flexibility of tipping point.
Tipping point is not a fixed point, because if a tipping occurs because three factors come together, it does not occur if only two factors come together. And it's a combination of these three factors, which comes first and in which combination. So it's not really determined. But if these three factors then come together, then it's very likely that the tipping occurs. But if there is a fourth intervening factor that avoids the tipping, then the tipping is prevented. And if you foresee a possible tipping coming because of the combination of these three factors, you could apply the fourth factor beforehand to avoid the tipping. So you have some way of avoiding the tipping if you foresee it.
Okay, I hope that is sufficient for answering this question. Then the next question is, do you think it is possible to detect where and when a conflict can be rising in the same way that we use, for instance, critical slowing down to detect proximity to tipping points? If so, what do you think are good observables for early warning systems?
Yeah, it's all depending on the sensitivity of conflict sensitivity. And conflict sensitivity is a function of these mutual couplings, these interaction matrix, which are called, and you see the different factors F, which are the connections between humans. So how my behavior affects your behavior, how your behavior affects my behavior, and how a third person affects our both behavior. These are the coupling terms. And I think if you are close to a positive eigenvalue in this interaction, which is an indicator of instability, this would be a possible way of getting early warning. Yeah. for instance, if we are close to an unstable relationship, shortly before this determinant is becoming negative, which I mentioned, that would be an indicator. Particularly if we have a hostile relationship with each other, and that hostility is increasing, there is a likelihood that this could lead to a conflict escalation.
Okay, thank you. Now I have Pia Johanna Schweitzer who wants to speak up.
Yes, thank you very much. Congratulations on this great talk. I would like to know how you operationalize sustainability in your models, and if you do that at all. So sustainability, I mean, the most straightforward way, as I see, is to frame it as sort of living within the planetary boundaries. But there are always also issues of social inequality and social justice. And I would be interested to know how you go about that. Thank you.
I would say every natural system has self-stabilizing mechanisms and also self-reproduction mechanisms. And if humans take action that lead to undermining this self-stabilization or overutilize and over-extract from the resources which are self-reproducing beyond the threshold, then it's unsustainable. Sustainability, at least in terms of environmental sustainability, is probably that what you ask, and because there's also social and economic sustainability terms, but I think you ask only for the environmental ecological sustainability. So I think it also has to do with how you understand stability, and if you destroy the self-stabilizing mechanisms of nature, then it's unsustainable. And you can take the example of fishery. Fishery has a certain reproduction rate. If the harvest is larger than this reproduction, then the fishery breaks down. It's unsustainable. The same for forest growth, the same for the for climate system, which reduces emissions, CO2 concentration naturally. If you exceed that natural extraction rate with additional emissions, then it's not sustainable.
Okay, thank you. Pia, is that enough, or did you want to?
Yeah, thank you. And how sort of, because, you know, you also mentioned those conflict dynamics, and that's what I find really very interesting. And is there an analogy that you could sort of also measure sustainability in the same way with regards to social aspects, social variables? Or is that a totally different kettle of fish?
I think you can bring both into the stability framework, because there is ecosystem stability theory since long time, I think, at least since the 1980s or 1960s. And you look also at the interaction between species, and the species have a certain, can apply the same interaction framework to the interaction between species, how one species affects the other species. And like a rainforest is an interaction system between species. And the ecosystem, like the rainforest, can be a stable one because it has evolved over a long time, because it has removed all the unstable elements in this system, and then can apply the same stability matrix framework like for human interaction. But the meaning of the terms in this matrix are different.
Thank you.
Okay. Thank you. We have to move on. We have 5 minutes left. We have 3 more questions. One is by Anselm Vogler wants to speak up and ask a question, so please.
Yes, thank you very much. And thank you, Professor Scheffran, first for this exciting talk. I will really try to make it short. First, could you elaborate on the role of chance, of random developments in this model? Is there any room for it? That's the first question. Second question, what about the data situation? I I admire the multitude of factors and their interplay, but to what extent can we actually get the data? Because often social science struggles with collecting the societal data to actually implement these models. How do you see the chance for that? Those are the two main questions, and maybe one last question. There are some researchers arguing when it comes to prediction and to research that less is more, including less factors would reduce measurement errors, and you include a lot of factors. Some in machine learning refer to that trade-off as bias variance dilemma or trade-off. I'm not an expert, just my question to you. Do you see a particular challenge arising from the multitude of factors that you include? But thank you very much.
Yeah, I think you mentioned three very important questions, of course, that apply to every modeling, in particular also for my approach. You mentioned the role of uncertainty, the role of data. Of course, each of the variables is uncertain. Okay, and the model as it is designed looks first of all like a deterministic model, even though it can be nonlinear. But every model has an uncertainty range, and when I applied this to the case of the Cold War modeling, I had an uncertainty range, okay, for each variable, and with this uncertainty range, both agents or superpowers could choose whether they use the upper or the lower part of that range, okay, and this was the worst case parameter. Worst case assumption they use the lower end of against the favor, and the upper end is to the upper part of the favor. So it's included in this model, this uncertainty range, which shows how completely different the results can be depending on the perception within this uncertainty range. Okay, so that can be included in the model. But the second is the model too complex? Yeah, or has too many variables? And yeah, I would say for the Cold War modeling, I think it had just the right number of models. I didn't want to make it more complicated. Of course, I could have included other agents like other countries like United Kingdom, China, and European countries and so on. But I think they were all part of the same superpower setting as their allies. Now in today's world, I would say it does not longer work in this two-agent framework. Yeah? We have to include more key agents. So you have to make it more complex to describe the current situation, because China was not included during East-West conflict. Now it is important. So we have at least 3 players. Now we have other European countries, Africa, India. More countries have to be included. So you have to adapt it to the situation as it currently is. And yeah, the same applies to which variables you take and choose. This is always up to discussion.
Okay, I think we have time for one last question. In the chat, I have a question about if this is only this research that you have discussed and described, is that only a subject for academia, or are there also funding organizations, foundations, private sector, consultancies, non-profits involved in such topics?
Yeah, I mean, the first part of my lecture was just dealing with the problem in qualitative analysis and some data analysis. I think that is more relevant for policymakers, decision makers, than the modeling. I think they want to know what are the data about climate and conflict, and what are the statistical correlations between them, and how can I influence this as a policymaker? What are the key control variables which I can influence to stabilize that relationship? They may be less interested in the modeling part. I would say this is more the academic part, except it's getting relevant for them. I would say maybe if anybody would have seen this model in 1989 in the summer before these events occurred, would have said, "Oh, is this possible that the Cold War can break down?" Nobody would have thought about this in summer 1989. It was only the model came up with this option that it could lead to a breakdown. But nobody, no media, no policymaker was ever thinking about this option that the Cold War could break down.
So you're saying they should be, like private sector consultancies, policymakers should be more aware and interested in this work that you're doing.
But I think today with climate change, the IPCC is extensively using models. And this is, they make projections about the future, and the policymakers take it for serious, obviously. Yeah. Now everybody is trying to follow the suggestions from scientists today based on these models. So it has a very strong influence.
Okay, great, thank you. We are 1 minute past 4 o'clock Oslo time or Europe time. I have actually two more questions. Maybe it's okay if, I mean, we are saving the chat, and you can, Juergen, you can maybe read and answer the people via email.
Yeah, everybody can send me an email, and I'm happy to share my presentation, and I think it was recorded also.
Yeah.
Yeah.
Okay, then I thank you very much, Juergen, and I thank the audience for a great engaged discussion with very important questions. And I welcome you to follow the website for the next webinar that is coming up in May.
Yeah.
Okay.
Thank you all for participating.
Thank you very much.